Okay, hello, welcome to our next part of our look at energy at Key Stage 4. Technically this is part 7, but obviously so we've combined a few lessons. Hopefully you know that, hopefully you've been watching. So what we're now looking at is our second of 3 parts of looking at the generation of electricity. The last time around we were looking at fossil fuels and nuclear power. Now what we're doing today is we're going to have a look at wind and water. So first of all we're going to start with wind power. Now we briefly mentioned this back in Key Stage 3. What that was basically an idea of exactly how the turbine itself worked. What we're going to have a look today is actually the ins and outs of exactly how the wind itself works. Now we've briefly mentioned about convection currents. We've been talking about convection in previous lessons. And convection currents is exactly how we have wind on our planet. What it's actually done is exactly the same way as we think of convection currents in water and convection currents we think in a room or any gas. What happens is obviously our air is heated. Now, where does the heat come from? Obviously the heat comes from our sun. The massive amount of heat that is produced from our sun is actually the cause of all the wind that we have on our planet. So the heat is actually, the heat is then transferred obviously to our air, and in a normal convection current, exactly the same way as any other convection system, the heat or the heated molecules of the air rise up. As they get to higher atmospheres, they start to cool, and the air again starts to sink back down. Now this is exactly the same, as I said, as any other convection system. So how does this exactly work? Now this is our equator here, this is our planet Earth, I hope you can recognise that. The way I've got here is our equator. Now this is obviously where the heat, where our planet is the closest to the sun. So this is where the thermal heat from the sun is at its peak. So across this equator, across this middle section here, is where the majority of the air itself is getting heated. This is why you find a lot of desert type land types across the equators, because there's so much hot air that the hot air is just immediately being raised up to heights. So as this convection currents show here, we've got our heat coming from the equator, it rises up towards the North Pole, and obviously as it goes down as well towards the South Pole. And it just keeps cycling round the equator. So this is how our wind systems work. So this is obviously an idea of how things happen from daytime to nighttime. So in daytime, when the sun's out, see that the hot air is rising up and it's sinking back down again. And our body of water, which is over here, is slowly getting heated by the sun as well. So actually when the night time comes, it's not actually no longer the sun that's actually heating up the air to cause this convection current. It's actually the stored thermal energy that we now have in our water body, which is actually giving off thermal energy to the air itself. So the convection current is almost reversed. It's still obviously the heat is still rising and then cooling and rising and cooling, but it's working in a separate way to when the sun was out. So all of these different types of convection and these convection currents, as I said, is what causes wind. So exactly how do we harness the wind power to then generate electricity? So this diagram you should recognise from our Key Stage 3 look at this type of energy source. So what actually happens is exactly the same as any turbine in any system that we've been talking about before. With the convection current, the wind passes through the blades of this turbine, which then converts the kinetic energy of the wind moving itself into a circular kinetic energy of the blade. As that blade turns, the turbine turns, which is connected to a generator, which again creates our electricity. As I said, it's exactly the same as any other turbine system. So what's the good and bad things about wind power? Well, the good things is it's clean energy. It doesn't produce any pollutions whatsoever. It has no fuel. The only fuel it needs is someone to blow on it. Obviously, I exaggerate. It needs a lot more wind than that. But, you know, it's very, very, very clean energy. And it's a renewable source of energy. We would hope that the sun's not going to stop shining the sky in the daytime, which means it's always going to produce heat, which means it's going to produce wind. So what's the disadvantages? Wind turbines are really quite expensive relative to the amount of energy they produce. to build, so they are relatively expensive. They're really quite noisy as well. Once they actually get going, they really are quite noisy. Now this one we've got here with a question mark next to it, unsightly. Now it's very documented that lots of people do not like the look of wind turbines. I must be weird because I think a lot of them look really quite nice. I'm not necessarily saying, you know, I'd like to live next to a farm of them, because I'll be honest with you, as I said, they produce such little energy that you would need lots and lots and lots of them in one particular space to create a noteworthy amount of electricity from them. But unsightly, that one's still out at the moment, whether people like them or dislike them. It's a bit like Marmite, really. But the other main downside is the fact that if there's no wind, then there's no energy being produced. So there's very specific as to where you can place them, as to whether you're going to get a good amount of electricity out of them. But the most important point, we've mentioned it before, for me the most important point, it's renewable. It's not going to run out, and it's clean. There's no pollution. So that was our look at wind power. Next we're going to have a look at water power. Now I call it water power because we're going to look at 4 different ways in which the power of water is harnessed and used to create electricity. Now the first one we're looking at here is the idea of taking the energy from waves and producing electricity from them. Now waves are a really good source of movement. They're a good source of kinetic movement. Waves are always moving, and what we have here are almost, I like to call them sea snakes. And what they're doing is they're floating on top of the waves, and this floating motion, this movement, this kinetic movement which is created, can be used and harnessed to create electricity. As I said, it's a good thing in terms of waves and the fact that they're always there, but again, they don't produce a massive amount of electricity. They're a relatively new invention, and they're always constantly being enhanced at the moment. So this is a relatively new one. So that's our first look. What's our second one? Our second one here is tidal. Now tidal, the powers of tides is actually enhanced and actually used to create electricity in 2 main different ways. The first one is this idea. Now again, this is just another turbine. So if you've ever been near the sea or a tidal river, you'll know that when the tide comes in, that lots of water comes rushing in, and up to a point that it's high tide, and then the water rushes back out again. And this is exactly what these turbines use. This motion of water is what they use. So as the water rushes in, as the tide's coming in, it spins this turbine, again connected to a generator, which creates our electricity. And as the tide flows back out again, it does exactly the same thing, but obviously in reverse. It spins the other way. But again, the concept is the same, that it's spinning a generator to create electricity. Third one is looking at a tidal bowers. This is the second way in which tides are used. Now this is very similar to something we mentioned in Key Stage 3, which is hydroelectric dams. It's very similar to this. What this actually is what's called a tidal barrage. So here we've got the sea. When the tide comes in, it's allowed to flow freely through our tidal barrage into what we call here an estuary, or our estuary basin. So when tide itself reaches its peak, this barrage is closed off, so the water is stored behind this barrage. So as you can see here, we had high tide here. Now at the point at which the tide has reached its lowest, what we have here is a store of water, which, if you remember from when we were talking about hydroelectric, is now actually a store of gravitational potential energy stored in our water. Because all we need to do is have a turbine here, release the water, gravity will automatically flow our water through that turbine, spinning that turbine and creating our electricity. And this leads to our fourth and final one, which is our hydroelectric power. We talked about this at Key Stage 3, we know exactly how this works. Again, it's built, it stores water behind it, massive amounts of gravitational potential energy stored before, which is then let out at the bottom, through flow, through a turbine, spins, creates electricity through our generator. So let's look at the advantages and the disadvantages of all of these. So our wave power, again, it's really good. It's a renewable, clean energy source. It's a reliable source of movement. Waves will continue to come as long as our moon is there and creating tides. the waves will constantly go there, and there is no fuel cost because it just relies on the water's movement. So what are the disadvantages? It's really expensive, really expensive to make because it's so new. And at the moment they're really struggling to make it on a scale that creates enough electricity to warrant the amount of money it's spent on it. So is this the future for clean power? I don't think so, but again, the plus side, it's renewable and it's clean. Tidal barrages. So what we've done, I've actually taken out the idea of our tidal turbine because the main things I'll use are these tidal barrages. Again, like our wave power, it's renewable, it's a reliable source of movement, there's no fuel costs apart from the initial cost of actually putting the barrage in. But what are the downsides? Again, it's expensive to build, and in this case, there's habitat destruction. Because what you're doing is actually effectively flooding what would have been an estuary, so there'll be lots of plants, lots of birds that would have lived in that estuary. As you're flooding it, you're destroying the habitat that they have there. But it is a good, reliable source of clean, pollution-free energy. That just needs to be weighed up against the environmental costs. Most importantly, it's renewable. We're not going to run out. It is very reliable. And our final one, a hydroelectric dam. Again, it's the top three. It's renewable, it's a reliable source of movement, there's no fuel costs. You know, it's free, they're not free, sorry. It's clean, pollutant-free energy. But again, the dams themselves are expensive to build. When you do build them, the amount of water that's held up behind them, it floods farmland, which will result in obviously a big exodus of having to move people from that farmland as well. A good example of that is the dam that was built on the Yangtze River in China, where millions of people had to be moved and a massive amount of land was flooded. Another downside of this is that because it's farmland, and the majority of the time it's farmland that's flooded, there could be vegetables, food products that are flooded there, which again, as they decay, produce methane, which again itself is a greenhouse gas. But, you know, it's good, it's reliable, it's essentially clean, and it's renewable. So, our overview. We know that both our wind and our water power sources are both renewable. Wind is a clean source, but where do you locate it? That's the major problem. Where do you locate it? Because you can't just have one, you need to have a big farm, lots and lots of them to produce enough electricity to warrant having them. Water, again, is a clean energy, but can have very large environmental costs. And can you weigh that up against the electricity that you get from it and from the pollution that's made from fossil fuels? So that is the big question. Are these better than fossil fuels? Okay, so that's the end of our second of generating electricity lessons. Our next lesson will be looking at electricity generation from geothermal and from solar sources. Cheers, thank you.